We're continuing with the Math 1113 final exam review, and we're picking up with question number 13 of 20 questions. Question 13 asks you, what is the period of y equals negative 3 times the cosine of 4.3x? So we're specifically asked to determine the period for this particular function. And really to find the period of any trigonometric function, it's a formula, and it's a formula. I don't recall if it's on your formula sheet. I'll try to look for you later, but you may want to look. If not, you may want to have it handy as you prepare to take the final exam. But the period for all the functions, with the exception of tangent and cotangent, the formula is 2 pi divided by b. And again, that works for sine, cosine, secant, and cosecant. If you happen to have one that's for tangent or cotangent, the formula is simply 1 pi divided by b. That's the formula for tangent and cotangent. Now, you may be wondering, well, okay, big deal, but where do you get this b from? Remember, it's the location of the numbers in the problem. In this case, the number out front, well, it's always the case, is letter A. The number inside the parentheses with the x is b. If there's a number added inside the parentheses, that's c. In this case, c is 0. And if there's a number tagged at the end, that's D. And again, in this case, that's 0. So my B here is 4.3. So I need to do 2 pi divided by 4.3. And I'm going to use my calculator to do that. I'm not going to worry about the pi initially. So I have 2 divided by 4.3. Which gives me 0.465 pi. Now, if I want to get a decimal approximation, I can use 3.1415 as the approximation for pi and multiply that, and I end up in terms of decimal, the period would be 1.46 radians. Now, as a side note, it's not the question that you're being asked, but as a side note, if you were asked to find the amplitude for your function is also a formula, and that formula is the absolute value of A. So for this problem, that would be the absolute value of negative 3, which is positive 3. Now, the negative is important because that negative tells me there is going to be a reflection on the x-axis. Okay, so you can't just ignore that. The D determines your vertical translation, moving it left or right, and C helps you to determine your phase shift. The easiest way to find your phase shift, which is something else you could be asked for, is to take the expression inside the parentheses, that bx minus c, and set it equal to 0. Whatever that expression is in the parentheses, set it equal to 0 and solve for x. And that's how you find your phase shift. So again, you may want to have those formulas handy as you're preparing for the final exam. Again, they may be on the formula sheet that's provided. I'll try to double check on that. Question 14 says, what quadrant does angle T lie, or in what quadrant does angle T lie if the secant of T is less than 0 and the sine of T is greater than 0? So ultimately, I want to know which quadrant, and so I'm thinking about my coordinate plane, and so it may help you to draw one and visualize what's taking place here. So I'm going to sketch one. We have, sorry about that, didn't get my marker back on track. Okay, so got my vertical line, that's my x-axis, and the horizontal, which is my y-axis. Okay, so I have those on my grid, and so then I have to think about, it says we have angle T, and I'm going to start with the fact that sine of T is greater than 0. This is kind of a logic reason it out problem. If the sine of T is greater than 0, that means that the sine value is positive. It also helps to remember that the sine corresponds to the y-coordinate of an ordered pair. So if I think about where would the sine be positive, the sine would be positive, or my y value would be positive here in quadrant 1, or possibly in quadrant 2. So I know that I'm in either quadrant 1 or quadrant 2. The other piece of information that I'm given about this angle that I'm looking for is that the secant is less than 0. The secant is the reciprocal of cosine. So by default then, that means that the cosine of t is less than 0. When something is less than 0, that implies that it's negative. The fact that, and again, cosine, we know, corresponds to the x coordinate. So then of my two remaining choices that I have to think about, is my cosine, where's my cosine negative? Is it going to be negative in the first quadrant or the second quadrant? My cosine is negative here in the second quadrant. So ultimately, the answer to my question, which is in which quadrant does angle T lie? Angle T would lie, T lies in quadrant 2. Okay, and honestly, guys, that's just a logic, reason it out type problem. There's really no fancy-dancy way to do it. You just got to think about the characteristics of sine, cosine, tangent, and where you would be on the coordinate grid system. All right, 15 is an application problem. It says a radio transmission tower is 331 feet tall. A guy wire is attached 6 feet from the top and is to make a 23-degree angle with the ground. And you're asked to find the length of the guy wire. Now, it may not be as obvious, but really what you're being asked to do here is use a right triangle. It doesn't explicitly say that. So we have, let's see if we can sketch a picture. We have the ground, if I can draw it. Okay. So we have the ground, and we have a radio transmission tower. Okay, so here's my tower. Okay, put me a little antenna up here on the top. Okay, and we're told that that is 331 feet tall from the ground to the top of the tower. We're then told that the guy wire is connected on the ground and is 6 feet from the top of the tower. So between where the guy wire is connected and the top of the tower, there is 6 feet. If the total is 331 feet, then I know that this distance from the ground to where the guy wire is connected is 331 minus 6, which is 325 feet. Okay, so the distance from the ground to where the guy wire is connected is 325 feet. Furthermore, we're told that the angle that's created between the ground and the guy wire is 23 degrees. Okay? And I ultimately want to know the length of the guy wire, which is this blue line here. So this is X. So hopefully you can see there that we have a right triangle. I know the side opposite the angle measure of 23 degrees, and I'm trying to determine the hypotenuse. And so that makes me think of my trig function. The sine of angle T is opposite over hypotenuse. The trigonometric relationship that involves opposite and hypotenuse is the sine function. So then I'm going to substitute into that equation the pieces of the problem that I know. So I know that the sine of 23 degrees is 325 over X. Okay, so I'm going to put sine 23 degrees over 1. And so that I have basically a fraction equal to a fraction, which we solve by cross multiplication. So I'm going to have X times the sine of 23 degrees equals 1 times 325. So I have X times the sine of 23 degrees equals 325. I'm trying to solve for X, so I'm going to divide both sides by sine 23 degrees. Okay, so I have X equals 325 divided by the sine of 23 degrees. And I'm going to enter that into my calculator. And I wish I had a calculator that I could put up on the screen for you to show you the buttons to push. But unfortunately, I don't. So let me see if I can write them out for you. Okay, so you would put 325 divide. Going to press the button that says sine. It should open a parenthesis. You're going to put 23 and close it. But now it's important that you check to ensure that your calculator is in degree mode. And you do that if you look at your calculator face at the very top next to the blue second button, there should be a button that says mode. So if I press the button that says mode, on the third line down, it says radian degree. And you want to make sure the word degree is highlighted. And so then you're going to type in 325 divide sine 23. And that gives you 831.77 feet. Okay, so my guy wire is 831.77 feet. Okay, that would be the length of my guy wire. All right, next question. 16 says, consider the equation. Cosine of 5t equals 0.8, and it wants you to find the smallest positive solution in radians. Well, one of the things that jumps out at me about this particular problem as we begin is that it's 5t, which is in trigonometry what we call a multiple angle, because it's not just plain old t, it's 5t. And so typically when you have a multiple angle, we use a process called substitution. Okay, and that is a technique that you see a lot in calculus. So again, with a multiple angle, and a multiple angle is anything like if you had 2t, 3t, 5t, negative 7t, okay, whatever. You got something other than plain old t, it's called a multiple angle. And when we have that, we use a process called substitution. Okay, and so here's how that works. We start out by saying we're going to let u equal that multiple angle, which in our case is 5t, so that I can rewrite the problem as the cosine of u equals 8/10. And then I need to solve that equation for u. Well, 0.8 is not one of my values that comes directly from the unit circle. And so then we need to use the inverse function. The inverse of cosine is arc cosine. So we're going to take, and I'll write it down here below it so you can see it better. We're going to take the arc cosine of both sides. So I'm going to take the arc cosine of the cosine of u, and that equals the arc cosine of 8/10. Again, it's the idea of inverse functions, and so the cosine and the arc cosine are inverses. They cancel one another off, just like addition and subtraction. So you have u equals the cosine of -1 times 8/10. Now, ultimately, in this problem, they've asked for the answer in radians. So when you go to put this in your calculator, you got to make sure that you are in radian mode. Again, to get in radian mode, press the mode button, which is on the top row of your calculator face. The third line down, you should see the words radian and degree. And you want to make sure that the word radian is highlighted. You arrow down, highlight the word radian, press enter. Then you should also see on your calculator face, there's a button. The button itself let's see, that's too far up. Let me move it down just a little bit. Okay, the button itself says cosine. But above that button in blue is cos to the -1. That's the arc cosine. And so I press the blue second button, then the cosine button, and I enter 0.8 and close the parenthesis. Again, ensuring that I'm in radian mode. So arc cosine of 0.8, I'm going to close the parentheses, and that equals 0.6435. Okay, and you round appropriately. But now, guys, don't stop short. Many of you will think, well, oh, I'm done now because I've solved for u. But remember, we're doing u substitution. So ultimately, u was 5t. So 5t is 0.6435. I'm ultimately trying to solve for t. So I'm going to divide both sides by 5. So t equals 0.1287 radians. Okay, and it only asks you for that one. It asks you for the smallest one. That would be the smallest one. There are others, but I don't need to spend time trying to find those because it only asked me to find the smallest one. All right, let's see if we can do one more and then we'll stop. Number 17 says, find all the solutions in the interval 0 to 2 pi for the equation 2 times the cosine of x minus the sine of 2x. So one of the first things I notice here is that I have an x and a 2x. That's like having an apple and an orange. But I have a formula for sine of 2x. There's actually several formulas. The one I like the best. The formula for sine of 2x is called the double angle formula. It's 2 sine x cosine x. So now everything would be in terms of x. So I'm going to use that equation, that identity, and make a substitution here. So I'm going to have 2 cosine x minus, and I'm going to take out the sine of 2x and put in this identity so that I have 2 sine x cosine x, and that's equal to 0. I'm only trying to solve for sine and cosine. Okay. I believe in this particular problem I have a common factor of 2 and cosine. Notice that both pieces here, you have to go back and remember some algebra. Both pieces have a 2, and both pieces have a cosine. So I'm going to factor out that common factor of 2 cosine x. That leaves me with 1 minus sine x, and that's equal to 0. Again, remembering the rules from algebra, we know that either 2 times the cosine of x equals to 0, or 1 minus the sine of x is equal to 0. And then I'm going to solve each of those effectively for cosine or sine, ultimately x. So I'm going to divide both sides by 2. So I find cosine of x equals 0. On the other hand, I'm going to add sine x to either side. So I have 1 equals sine x. So the question comes here, where on the unit circle does cosine equal 0? So picturing, need to picture the unit circle. Okay, the cosine corresponds to x values. And so at this point, which is 0, I have the ordered pair 1, 0. At this angle, which is pi halves, I have 0, 1. At pi, we have the value negative 1, 0. And then at 3 pi halves, we have 0, negative 1. So if I think about it, the cosine is 0 whenever x equals pi halves, or x equals 3 pi halves. Then the other question there is, where is the sine equal to positive 1? The sine is positive 1 at pi halves. Well, I already have pi halves included as one of my answers. So ultimately, my two answers here are pi halves and 3 pi halves, and that satisfies both pieces of the equation. Okay, we've got about 4 more questions to go, and we'll do that on a separate video.